Multiplayer games are pretty cool. Who doesn't want to make the next World of Warcraft, CSGO, Overwatch, Fortnite or League of Legends? But to do that, you'll need two things. First, you'll need a solid understanding of multiplayer principles and the networking used in online games. And second, you'll need a lot of money. And while unfortunately I can't help you with that second one, I can and will help you with the first. So in this video I'm going to give you a high level overview of how multiplayer games actually work and how you can get started making them in Unity or any engine really. To make a game multiplayer, all you need to do is be able to transmit messages between players. That's it. If I'm playing a game of chess online and I make a move, that move needs to be relayed to my opponent. And the way we do that is via messages we call packets. In an online chess game, when someone makes a move, that move is converted into a network message and sent across the internet in a series of packets, which are just bundles of data. For chess, the message is very simple. It's just the starting position of the piece before I move it and the end position of the piece after I move it. With this information alone, my opponent can see exactly what I've done, and once they've received this message, they can update their board with the information. And that's it, you've got a networked game. This core concept of converting actions in a game to a message that can be sent to other players is what makes up all multiplayer games. Even real-time games like CSGO, Overwatch and League of Legends use this method to deliver the online experiences you know and may or may not love. When you move in Overwatch, the world position of your hero will be bundled up into a network message and sent to all the other players in the game. When you activate an ability in LoL, that action will be converted to a net message and sent to other players, who will update their game to show your champion activating an ability on their screen. Now, the exact witchcraft and wizardry these games employ to deliver a seamless multiplayer experience is for another video, but for now all you need to understand is that to make an online game, you simply need four things. First, you need a way of converting the actions players make in their game into net messages. Then you need a way of sending those messages across the internet to other players. You need a way of receiving those messages in each player's game. And finally, a way of updating a player's game according to the data received in those messages. Now, you're probably thinking that sounds all fine and dandy, but how does one go about implementing these things into a game? After all, building up a multiplayer game does take many hours. But to answer that, we need to talk about what it looks like when a packet is sent from one player to another. And if you first, the player makes an action in their game. This action is then converted to a message so that it can be sent across the internet. Once this message is wrapped up and ready, we then use something called a transport layer to send it to another player. The transport layer is responsible for breaking the message up into a series of packets and establishing communication with other hosts on the network, so you actually have someone to send those packets to. This layer also does a few other things, but those two functions are its key responsibilities. Once the message has been sent out, the other players will start to receive the packets via the transport layer, which reassembles the packets into a message that your application can then use to update its game state. For example, moving another player, causing bullets to be fired or an ability to be used. Now, while that might sound a bit intimidating, fortunately for you, that's where networking libraries come in. In this networking diagram, you only really need to create the top layer yourself, which is the game, because, no one's going to do that for you unfortunately. But the second layer where the player's action is converted to a net message, and the transport layer where the message is broken down into packets and sent across the internet. Luckily for you, some clever people have already done that and provided libraries you can use. If you've done any sort of research around multiplayer in Unity, you'll have likely heard of Mirror, Photon, Netcode for Game Objects, and maybe some others. These are all networking libraries that handle converting your game actions into net messages and use their own transport layers to send and receive those messages to and from other players. Now, to be honest, I've never used any of these libraries because I've always written the networking layer myself from scratch. And while that might make me sound like an absolute gigachad, it's actually just because for the longest time I didn't really know what any of these libraries actually did. So if you're starting out making multiplayer games, I suggest you save yourself some time and use a networking library. Consider checking out Netcode for Game Objects, since that's the official Unity multiplayer solution. There's a link in the description to a video on it by this lovely gentleman who goes through how to set it up. Additionally, you can never go wrong with a CodeMonkey tutorial, and he has a very in-depth one on Unity's networking solution you should check out. So now hopefully you have a pretty solid understanding about the core principles of networking used in multiplayer games. And for the second part of this video, I'm going to actually jump into Unity and write some code so I can show you at a low level how exactly network messages are sent. Now, this isn't a tutorial about how to implement networking into your games, it's just to give you a deeper understanding of the sending and receiving of network messages. Please don't try and copy line for line what I'm about to show you, it's just to illustrate the core networking concepts I've mentioned. Okay, so I'm in Unity, and what I want to do is type a message into this chat box and have this text message be sent to another player in my game. Right now, the message is only posting to my chat box, not anyone else's. The way we're going to send this message to other players in our game is conceptually the same as sending any other type of information we need to enable a multiplayer experience. For example, player movement, weapons being fired, the placement of a unit in Clash Royale, and so on. This information can all be sent via network messages. The major difference is just the data we choose to send. So while in a player movement message we would send data to represent a player's position, such as an integer, float, short, or whatever, in this text chat message we're just going to send a string of the message a player has typed out. Looking at the 4 things we need to make a multiplayer game, the first thing is a way of converting the actions of players to net messages. The action in this case is a player typing something out and posting it to our chat. To convert this action to a net message we can send across the internet, we first need a network message. So what we're going to do is create a class called netMessageChat. This is going to be the network message we send to other players that contains our game data, in this case a string. So we create the class and define a field that will hold our chat message. We can't use the normal data type of string in this net message, instead we need to use a fixed string. The size and order of the data we send across the web in network messages is critical to receiving the information correctly. So we need to be explicit about the size of the data we're sending, in this case a string of 128 bytes. Next, we need to store the action our player has made in this field we've just defined. So we'll create a constructor that takes in a parameter that will be the message our player has just posted. Think of it like this: when the player posts a text chat, their game needs to create a new instance of the network message that will contain the text chat that we want to send to other clients. When we create this network message, it should contain a string that corresponds to the text chat the player has just posted. So by using this constructor, when we construct the new instance of the network message, we give it the text that the player has just typed out. If you're new to constructors, replay the last 30 seconds a few times to try and understand what I'm talking about. Okay, now we've got our message containing the data we want to send from one player to another, we just need to get ready to send it. Unfortunately, we can't just clip it and ship it as is, because if you remember, we don't send messages as a whole, we break them down and send them as packets of data. So to do this, we need to perform something called serialization. Essentially, this converts the data we have in our net message, in this case a string of our player's text chat, to a more condensed format that is easier to send over the network and consequently to other players in our game. Don't worry too much about understanding this part, because as I mentioned, networking libraries handle this all for you. They will handle converting the player's text input into a net message, serializing it and then sending it off. We're just doing this ourselves because, well, I don't really know why we're doing this to be honest, but we may as well finish what we started. So anyway, in this function we will serialize the data we want to send across the web, but to do that we need one more thing. And if you have any experience with networking, you're probably wondering how in Tarnation I've made it almost 10 minutes into a video about multiplayer without mentioning the words client or server. But now their time has come. We're moving on to point 2 of 4 on our list, where we now need a way of sending these net messages we've created across the internet. To do this, we're going to use a client-server model. As I said before, the only thing you need for a multiplayer game is a way to send messages between players. A common way of doing this is using the client-server network topology. Essentially, each player in a game is a client, and at the start of the game they will connect to that game's server. Then, when they want to send network messages to each other, they do so via the server they're all connected to. Player 1 will send a message to the server, and then the server will broadcast that message to all other players. And it's as simple as that. So in our game, if we want to send our text chat from one player to another, we'll need a client for each player and one server to relay their messages. Again, networking libraries will handle all the client and server code for you, but for this video I've got a very rudimentary class that uses Unity's transport layer. This is the client script, but don't get spooked, you don't have to worry about what's happening in this class. All you need to know is that at the start of the game we will call this function, which will connect us to the server. Then in the update function, which is run once every frame, we are simply listening for any update we receive from the server. Remember, once we're connected to the server, we're relying on it to pass us any messages from other players in our game, for example any text they type into the chat. And finally, I have this function which is responsible for sending a network message to the server. Consequently, it will take in the netMessage chat object we create when the player posts something to the text box. So when we want to send a message to the server, we'll call this function. It will then prepare to send the message to the server using what's called a network driver. Serialize the message using the serialize function we defined in our netMessage class, and then finish sending the message. And there we go, that's all our client needs to send a message to the server. The only thing remaining is to finish our serialization logic in the netMessage. What we're doing in this function is breaking up the message into packets so that we can send the data as a stream of information over the net. To do this, we'll need the data stream writer we got when we began sending the message in the client script. I glossed over this part in the center server function, but for now all you need to know is that the writer is what enables us to convert this message into packets we can send across the web. So in our serialization function, all we do is call the function writeFixString128 and pass in the string we want to serialize. You can see that the data stream writer has functions for writing all sorts of data types, so depending on the data contained in the netMessage you're sending across, you can use the relevant function. So we've now handled all the logic in our netMessage responsible for converting the action made by the player to something we can send across the web. The last thing to do is actually create an instance of the netMessage from our text chat script, which I'll do when the player clicks the button to post the chat. Once we've created the message using the chat input from the player, we'll call the center server function on the client, passing in the netMessage we've just constructed. I'm going to use findObjectOfType a couple times in this demonstration, which is not great and should rarely be used, but I'm trying to keep things simple, so please don't savage me too hard for using it in the comments. Once we've done this, we've now handled all the logic necessary for step 2 by creating a way to send net messages across the internet to other players. Hopefully you're starting to see the value in using a networking library which handles all this malarkey for you. So now that we can send data from one game, we need a way of receiving that data in another game. And as I mentioned earlier, in a client-server model, the message doesn't get sent directly to other players, but instead goes via a server. So for every game we have players in, we'll need a server to act as a relay for their communication. Here is an example of a server using Unity's transport layer. I'll admit it looks slightly spookier than the client, but it broadly follows the same design. When the server starts, which is usually just before the game begins, it'll set itself up by defining an IP and port number that clients can connect to. It'll then create a list of connections that will hold all the players that are connected to it. At the very start this list will be empty, but every time a player connects to the server, which will be when they join the game, they will be added to this list. The server also has an update function which does a few more things than the client's update function. But you don't have to worry about that, instead we'll focus on this part, which is where the server listens for data being sent to it from the clients, which are just players in the game. And here, this is where the magic happens. The server is listening to the clients every frame, and once it receives some data, we're in business. Here we've got the data that the client sent in its netMessage, and we can do whatever we want to it. I'm going to add the number 69 to the end of the message before I pass it on to the other clients in the game. But to do that, we first need to do the opposite of what we did when sending the message from the client. We need to deserialize the message. When we sent the network message, we essentially converted the data in that message, which in our case was the text the player typed into the chat, into a stream of bytes. We then sent this stream to the server. This serialization made it easy to send across the web, but hard to read. So when we deserialize the message on the server, we're just taking all the bytes of data, the packets that we received, and using them to recreate our original net message. This is a crucial concept to understand. When we're sending data from the client and receiving it on the server, we're doing it via packets of data that together make up the net message. we are not sending the message itself. So to recreate the original message using the data packets we've got, we do something called deserialization. And to do that, we're going to need another constructor. This time, when we construct the message on the server, we're not passing in a string like we did on the client, but instead passing in the data stream reader. This object represents the stream of packets that make up the overall net message. And in this constructor, we will call a new deserialize function passing in the reader, which is just the data packets. Now when we receive the data on the server, we are going to create a new net message using the constructor we just made, which will put all the data packets back together to construct an identical copy of the net message that the client initially made on their game before breaking it up so they could send it to us. Now we've got a new instance of this net message in our server class, but right now it's empty. Back in the net message class, this chat message at the top is blank. By deserializing the data stream we got from the server here, we are able to populate this field with the fixed string we initially sent from the client. And now once we've done that, we're golden. We've successfully received the message our client sent. As promised, we can change the message to do a little trolling, and now we're just going to repeat what we've already done. We want to send this message that we've received from one player to all the other players in our game. To do that, I've got two functions in my server class: broadcast and send to client. The send to client function does something very similar to the send to server function we defined on the client. It prepares to send the message, serializes it so that it's easy to send across the network, and then finishes the send. The only difference is that we're specifying a particular client to send this message to in the function signature. In the case of a broadcast, which just means we're sending the message to every player in the game, we simply loop through the list of connections I mentioned earlier and call the send to client function for each of them. So once we've received the message and tidied it up a bit, we can broadcast it to all players in the game. And that's the server done and dusted. Once the server has sent the message to all the players in the game, we just need to handle the receive on the client. Back in the client script, we go to the update function where we're listening for incoming messages from the server, and in this part here, we know we've received some data from the server. So we can do the exact same thing we did on the server when it received some data. Create a new instance of the message. The message is currently blank, so we run our deserialize function on it to populate it with the data we received from the data stream. And boom, step 3 completes. We now have a way of receiving network messages in our game. The fourth and final step is to do something with the message we've just created. In this case, I'm going to pass the net message to my chatbox handler, which will display the string contained in the chat message field on the screen. Now to get all this working, we need to do one last thing, which is to specify the IP and port number we want to use to communicate. I'm going to create a small class with two functions that I'm going to hook up to some buttons. The first function will create a host. A host is simply a player that is both the server and the client. Remember, we always need a server to relay messages to and from clients, but every player must be a client so that they can send messages to other players in the game. It is quite common for one player in the game to act as a server which messages get sent to and from instead of creating a separate dedicated server. However, this player is also a client and so is able to send the actions it makes to others, hence we call them the host. The second function will create a client, which is just a normal player that can send and receive messages. In this function, we will initialize the client by running the init function in our client script that connects to a specific IP address and port. The IP address we will connect to is 127.0.0.1. You can think of this as the IP address of the computer you're using right now. This will establish an IP connection to the same machine or computer being used by the client right now, which in this case is just us. Then I'll use a random unused port number. You can go wild here. In the host function, we will run the init function on the server to set it up, passing in the port number we are using in the client function. Because the host acts as both a server and a client, we need to also initialize the client, so we'll call the second function as well. Right, finally we're almost there. We'll create the buttons, hook up our script, and make sure we've got our client and server in the scene. If we have two games running side by side, join the game as a host on one and a client on the other, we click in our text box and drop some knowledge. And just like that, we've got a multiplayer game. Now I really wanted to end the video on that dramatic note, but thought I should clarify a few things before we finish. First, if you're going to start developing a multiplayer game, look up Parallel Sync. Developing a multiplayer game without it would be incredibly painful. Second, as I mentioned, I really don't recommend using this approach for your games since it's a lot of unnecessary work when you could just use a library that does this all for you. I only went through it to elaborate on the high level points I mentioned in the first half of the video. Despite saying this, I know some of you rogues out there are still going to want to use it anyway, and if that's the case, then listen up. First, don't copy this setup, it will absolutely not scale. For one, we can only handle this single message. What you need is a base class for all net messages to derive from, which defines virtual functions that every type of net message, from moving to attacking to placing troops to whatever, can override. Then the first byte of each message will need a unique identifier that can be read on the receiver's side so they know what type of message they're receiving and can deserialize it accordingly. Additionally, you'll need a better way of receiving messages on your server and client to account for the fact the message can be of any type, and this should not be handled directly in your server or client class, but instead handled elsewhere. If that complexity hasn't scared you off, then check out the description for a YouTube course on using Unity's transport layer that I've demonstrated here. It'll point you in the right direction. Otherwise, check out the networking libraries I've mentioned, and good luck.